We are on to section 2.2 in our textbook. So we now have a formula to calculate the slope of functions which are not lines. And we're calling this idea the derivative of a function. So the new idea for this section is that the derivative of a function is a new function. So let's say that I have some function f, and I want to find its slope at the coordinate x equals a. So we've already seen the difference quotient formula. We are taking the limit as h goes to 0, and the quantity we are evaluating is f of a plus h minus f of a, all divided by h. Now, we've already seen that this limit can produce different values depending on what number a I'm evaluating it at. So functions which aren't just flat lines can have different slopes at different coordinates. For that reason, I'm going to take my derivative, which I am writing as f prime of a. I'm going to say that that's just defining a new function. We'll call it f prime of x. So whatever my original function is, f of x, if its derivative exists, if this limit exists, then its derivative is going to be some other function. So I like to think of this stuff in terms of the geometry of what's going on, the picture of the graph of the function. And I like to tie this idea to the slope of that graph of the original function. So for example, here in blue is a curve that we are identifying as y equals f of x. We don't have a formula for f of x right now, that's okay. But at any x coordinate, I can imagine putting in a tangent line and measuring the slope of that tangent line. So for every coordinate x, there's going to be some value of the derivative function. That derivative will exist there. Now, if I was going to actually draw in my tangent lines, here are some examples of those. And that derivative function is going to have its own graph as well. So here in blue is the original function f of x. And here below it, we've drawn the xy coordinate plane a second time. And we've graphed the function y equals f prime of x in pink. How do I know that the pink function is the derivative of the blue function? Well, we have highlighted some spots here where we've actually gone ahead and drawn tangent lines. So at this point A, it looks like maybe x coordinate about a half. I see that the slope of my tangent line must be 0. This is a horizontal line, so slope 0, no rise over whatever amount of run I want it to be. That tells me that the derivative, f prime of x, has to take the value 0 when x equals 1/2. And I see that right here where it's marked on the pink graph. That's the same reasoning at points B and C. Every time I have a slope of 0, every time the tangent line was horizontal, that will be a place where the derivative of the function has to be equal to 0. Those will all be places where the graph of the function touches the x-axis.